Welcome again. In this little video, I'll show you something about branches. So first of all, let's make a recap. I'm introducing you a new command, is a really useful command, git log. Git log shows you the history of the file. So now it tells me that I've done the first commit and then another commit. And I want you to remind one interesting thing. If I'm copying the commit ID, I can use the git cat file -p and I can print the content of the commit. And as you can see, it has a parent. Okay, so now what I have is that each commit has an ID, and then it has parent, a nice parent ID that points to the parent. So it is a chain. Each commit has a parent, and so on, so on, so on, until you find the first commit that, if you say get cat file -p, and I'm taking the parent commit, it has no parent commit, so it's the first commit. Now a question arises. How can Git understand which is the first commit? So when I issue the git log file, how can Git find the address of the first commit, since there's no other commit that is referencing that commit? It turns out that if you're going to design Git, the most simple way to place this information is in a file. And if you open the .git internal Git repository and open ref heads, this kind of structure will be clear in a future video. But for now, let me show you that we have in ref heads one file called master, and that file actually is containing the same ID of the file, of the first commit. Okay? Now, this means that Git understands which is the most recent commit looking to this file. Actually, it's a little bit different because we have another interesting file that is called head. And if you open the head file, you see that's refs heads master. Now, to understand how Git works, you need to understand this. In the head file, there is an information on what Git expects to see in the working folder. So in the folder you are working with, okay? And usually you have one refs heads something. You usually have reference to one file that contains the commit. So what is happening when you issue a new commit is that Git create the commit, as you see in the previous video, get the new ID of the commit, and update the file that's referenced in the head. And the head represents the point, the snapshot that it's referenced by the working folder. Now, to better understand how everything works, we have our hello Git files. It has a two line, a comment and a console log. Now, if I use git no pager log one line, it's one line. It's a nice way of telling it not using less pager and logging one commit for each line. So I have a very compact view of my history. Now I'm in DADDC0B, and so the head is pointing to the master. So everything I've showed you about head and master, it's represented in this compact view. Now let's copy the first commit, and let's say I want to look how the folder was when I did my first commit. I can use the command git checkout. Checkout is a real complex command. It does a lot of things. For now, understand that if you issue a git checkout with an ID of the commit, actually, as you see, the content of the file changes. So git checkout actually takes the working folder, takes the folder you're working with, the same content of the commit. So you actually use a time machine, and now you are looking at the files how they were in the first commit. And there are a lot of warning. It will be clear later, and it's warning you that you are in a strange situation. If I issue a git no pager log one line, so you see something strange. My latest commit, it's gone. I'm seeing only the first commit, because actually I've moved my head back in time and I have no point on master, so it's called a detached head. But for now, let's say that you usually use a git checkout with some name like master. That's bring you back on the master branch, because that is called the branch, and you are back to your first situation. Now, let's move out copying everything to a Windows machine, because in Windows I have a nice utility that helps me showing you a little bit more graphically things about what's inside the repository. And that helps me to even reinforce the concept of how it is done. So if I want to transfer this repository on another computer, I can simply take the .git folder. And if you remember, I told you this folder contains everything about your database. Okay, now I can verify with get status that I've nothing changed, so everything is okay. I can copy and paste the .git folder in a shared folder. Now I'm moving on a Windows machine, and in this Windows machine, I can take the .git folder from my share and move to another folder. Now I can open a Git with standard Visual Studio Code. Okay, so now I've transferred only my .git file, and I can do a git checkout master. And it is telling me that I'm already on master and I've deleted the file. So what happened is I've transferred only the internal database. So when it's not an operation you are doing frequently. But if you are moving on the .git folder, you need to issue that command. As you see, the content of the working file, it's come back to the real content. Okay, git checkout as another option, and --dot it's telling Git to issue a checkout for each file of the directory. So actually Git examine the branch we are in, and we are master, and it is actually taking all file of the folder and bring back those file to the original content. As an example, if I'm modifying a file, I save the file, I issue a get status, it tells me that the file is modified. If I'm issuing again a git checkout --dot, I'm telling undo all my modification, take all the file of my working folder, confront with the hashes in the index file, and if it's different, bring back to the original content. And so, okay, file is gone, my modifications are gone. And git checkout --dot, it's the way of undoing all your local modification. And be wary, be cautious with this command, because this is actually deleting all of your uncommitted changes. Now I want to show you a little nice tool called Git Works, and it is tool on Windows, and I can simply take the folder you want to monitor, and yes, as you can see, it is showing you nice graphical representation on what's inside the Git repository. And this is nice because it helps me to show you some interesting stuff. Now, I want you to show a brief introduction to branches. Now, suppose I want to correct a bug. I have a bug 123. So I want to correct this bug in a different line of develop. So I'm using Git Branch bug 123. And this actually create a branch. It does not tell me anything, but actually, if you see the ref as folder inside the .git, I have another file called bug123, and it has the same content of master. So actually, if I issue a git log one line, I've got that still I have my head pointing on master, and I have another branch, and that branch is on the same commit. Now, git checkout, it's the same command you see before, but now I can show you that if you issue a git check out bug123, you are switching branch. Switching branch mean that if I'm issuing a git log, my head now is pointing to bug123. This means, in turn, the end of the situation is if I'm modifying a file, another comment for bug123, okay? I issue standard get status. It tells me that the file is modified. I issue get add dot to add modification, and I git commit with a comment, I'm trying to fix 123. Now, if I issue git log one line again, I see that I have my head pointing to my new branch, and that's the commit my branch are in. Then I have my master branch on the second commit, and if I'm looking at git vids, it shows me the situation in a nice graphical way. Now, let's suppose that I've not still finished bug123, but some person in the team tells me that I need to fix the bug 1.2 or the bug 1.2.3.4. So I can check out my master branch, because my master branch is the branch that is stable. So if you come back to master, the head is now pointing to master. The new commit done in the bug123 branch, it seems to be gone, but it's always there. It's just pointed by a different file. So in the ref heads, you have now the master file pointing to this commit and the bug pointing to another commit. So all the simple text files are simply containing branches. Now, if I want to fix another bug, as an example, I could use Git Branch and telling it the name of the new branch. But I can do something a little bit tricky. You're not going to do this in any way, but this helps me to show you how Git is working. If I'm copying the master file and I'm pasting and I'm calling bug 777, okay, I've just created a file with the same content of the master. If I telling it to list all the branch I have, now I have another branch. So a branches git is nothing else than a file with a commit. Now I can issue a git checkout bug 777, okay? And I'm now on the branch bug 777, okay? Now I can take the hello git file and write another comment and say this comment is for 777 bug, okay? I'm saving as usual git status. I've modified the file, git add. I'm adding a file, git commit -m fixed 777. And now if I issue git log one line, I can verify that it's a similar situation as before. I fixed the bug and I've created a master branch. Let's look at this file. If I'm now issue a git checkout and I'm telling it to check out the branch 123, so I'm moving on another branch, a couple of things happens. First of all the content of all the files monitored by Git were immediately changed to the version of that branch, and then the head is pointing to my new branch, and I have still the master file, the master branch unchanged. So that's the situation. I've done modification on a branch, I've done a modification on another branch, and the situation is this. I have the master branch and two different branches. So that's allow Git to work in different bug feature independently by branch that's usually the stable and the master branch. And everything is done simply with simple text files that are used to point to a commit. And it is really similar to snapshot in virtual machine. So the idea is this is a tree. Every time you issue a git commit, you are taking a snapshot of the folder. As you should remember, it's like zipping all the content of the folder and giving an ID. Then you start doing modification, and you keep track on those modification with a file that points to the first commit. So you can create how many files that points to how many commit you want. And actually the situation is I have this common zip with the content of the folder at a certain point in time. Then I've done modification and I'm creating another zip, another snapshot. And then starting from the same master commit, I've done other modification and I've created other snapshots. So actually the story of that folder diverged. Now in the next video, I'll show you how you can take all this modification and bring back to a single line of code. For now, you should only understand that if you're working in command line, you have git log -- one line -- decorate -- all, and that's allow you to have a little bit of information. So now you are looking at all the branch you have. So now the log, even if I'm in the bug 123 and the bug 777 is not included in the bug 23, because bug 23 have this commit point to this other commit, and this commit point to this commit. So if I'm following all the line until I reach the first commit, the bug 77 branch doesn't come into the path. So if you use -- all, you are looking at all the branch, and you have also graph that allows you to look at the similar graphic representation you have with the Git vids tool, but this time in command line. But actually it helps you understanding that you really have the master branch, and then you develop the bug 123, and then in parallel you develop the bug 777. And that's pretty much everything on our branches. A branch is only a file, and this file only point to a commit, and from that commit you have all your history descending from the commit to parent to parent to parent until you find the first commit. That's all for this video.